Okay, welcome back to some more fun with math. In this video, we're going to look a little bit more at some fractions and some mixed numbers, and we're going to look at some examples on how to work with fractions and solving different types of problems using fractions and mixed numbers. So one thing that we need to note is that we have three types of fractions. So the first thing we have here is called proper fractions. Okay, and a proper fraction means that the numerator is less than the denominator. Okay, so what that's actually telling us is essentially that the top is smaller than the bottom. Okay, so that is what a proper fraction is telling us. Now, an improper fraction is kind of the exact opposite. Instead of the top being smaller than the bottom, now we're looking at where your numerator is either equal to or greater than the denominator, meaning the top is bigger than the bottom. Okay, so here that's what we're looking at. We're looking at that the top is bigger than the bottom. Okay, so that is improper fractions. Now when we're talking about a mixed number is just as simple as you're taking a whole number and you're adding a proper fraction onto the back end, thus making it mixed. Okay. Now with fractions, we have to know how to write them in a couple different ways. One of those ways is being able to write fractions based on given pictures. And so what that means is that you have to be able to know how to take something that you're seeing and actually turn it into a mathematical fraction. So there's a simple way to do that. When we're talking about the picture, the fraction itself is created obviously by determining which part of your image is the numerator and which part of the image is the denominator. Your numerator will be found by counting the shaded regions in whatever figure or image you're looking at. The denominator is going to be the total. Okay, so how many total shaded and unshaded regions did your image have? Okay, so I wanted to show a couple examples of doing just that. So here for the first one, it says we need to write a fraction for the shaded portion. Okay, so in order to do that, we need to look very carefully at how our definitions are going to apply. So first and foremost, your denominator is going to be the number of blocks in a single row. Okay. Now, the reason why we know to do that is because here my rows are separated. So we are talking about the number of blocks that we have in a single row. So in this case, if we look at just a single row, we can simply call this, say, row A, and we can call this row B. And what you should notice about row A is that it has 4 blocks total. Well, row B has the same, which is 4 blocks total. So when we're talking about our fraction, the denominator of our fraction comes from the number of blocks in a single row. So in this case, this means we are looking at 4. Now, if we talk about the numerator, your numerator is going to come from your total number of shaded blocks. So shaded blocks usually means the ones with color. So when we're talking about the total number of shaded blocks, we are talking about how many out of both of these rows are purple. Well, I've got 1, 2, 3, 4, 5, so my numerator is 5. Therefore, if I put it all together, it means my fraction here for this picture is going to be 5 over 4. And unless you are asked specifically for a mixed number, it is generally accepted and understood that the improper fraction would be your answer. Okay? So let's look at another one. Okay? So again here, if we talk about your denominator, so another word that we like to use is we like to call it the bottom. So again, remember the bottom is going to be found by the number of blocks in a single row. Okay. So if you look, notice I have multiple sets, but notice all of these have a space between them. So when we're talking about a single row, we are talking literally about, say, this chunk. Okay, so maybe we call this one A. And if you look at it, we have how many blocks? Well, there's only 2 here. So therefore, my bottom is going to be 2. Now, if we look at the top, again, remember, your top, or the numerator, is going to be your total number of shaded blocks. Or the total number of whatever color you were told. So here we're talking about the shaded, and notice here we're asking to do both the improper and a mixed. And so here we want to see both. And so when I'm looking at the number of shaded blocks, I just simply have to count out the number of purples. So 1, 2, 3, 4, 5, 6, and 7. So that means my improper fraction is going to be 7 divided by 2. And then in order to find the mixed number, says again we need to perform, say, old school long division. So if we look at that, what we have to remember here is to find the mixed number, we got to set up our division. And to do that, essentially says that we have to figure out how many times, or what 7.5 is going to be. Okay? And so for that, we have to be able to put my numerator underneath the division sign, your denominator outside the division sign, and then we run old school division. So 2 can go into 7. Well, it can go into 7 3 times, because 2 times 3 is 6. So we have to subtract the 6 away, leaves us with a 1. So what we have to remember out of this is we have to remember that this part up here, or your result, is going to be your whole number. Your remainder down here is going to be your new top, and your bottom remains your bottom. So in this case, when we are talking about the mixed number, we are talking about 3 and 1/2. So here we would have 2 solutions, the improper, which is 7/2, and the mixed, which was 3.5. Okay. Now, another thing that we have to do fairly often is we have to be able to read applications which is a big fancy word for story problems. And we have to be able to create our fractions or our information based on what's given. So we have to be able to do what's called identify the whole and identify the part. So the whole is talking about the denominator. Okay, it is talking about what is the overall total value that we are looking at. And the part is what or how much of the total value are we actually talking about. So here we have that there are 32 students in a classroom and that the number of male students is 17. And we want you to write a fraction for each statement below. The first statement says the number of male students to total students. So when we're talking about the part, remember the part is going to be the top, and in this case we're talking about male students. The whole, which is the bottom, is talking about your total. So if I want to write a fraction, I'm looking at male over my total. Well, the problem told me that there are 17 male students and there were 32 students in the classroom. So that is all you're actually looking for that first part. Now the second part wants to know the number of female students to male students. So the first thing we need to do there is we need to find how many female students we have. To do that, says you need to take your total, so that's the 32, minus your male students, which is 17, because that's going to leave behind your female students. So 32 minus 17 is 15. So now we want to know the number of females to males. So when we're looking at that, females comes first. So this right here is going to be your top. We then have males come second. So this is going to be the bottom. And lo and behold, this little 2 signifies your fraction. So we need to go ahead and do that. We're going to have our fraction being female over your male. So my female was 15 students, my males were 17. And again, that is all that you would need to do for this type of problem. Okay? Now, a biggie when we're dealing with fractions are basic rules for simplifying. Okay? So whenever we're working with a fraction, once you've identified or designed that fraction, you have to look and see if it fits into one of our rules. Okay? So these are the rules for simplifying. Now, one of the things that we have to remember is that any number over 1 equals that number. Okay? Now the other thing that we have to remember, so that's the first thing. The second thing we have to remember is that any number over itself gives you 1 as a result. The third thing we have to remember is that any number divided by 0 is undefined. Another way that we like to represent that is UND. And the last thing that we have to remember is that 0 over any number will always give 0 as a result. So these are kind of our 4 rules that we have to use or put in place when dealing with fractions specifically. And so here, for example, I have 8 over 1. Well, that's going to fit with this first rule that says any number over 1 is itself, which means this is going to simplify to 8. Which means when you're doing your work, if you reduce a fraction down to where it says a number over 1, you must simplify that one step further and tell us that the answer is actually that number. Okay? Our second one has 12 over 12. So notice those are going to be the same number. Again, when you simplify, this gives you 1 as an answer. Okay? This third one says we have 3 over 0. So we have to remember that this is undefined. Okay? You could also again write UND. And last but not least, if the 0 is on top, then a 0 you should write. So those are kind of the 4 rules that you must always follow when looking at fractions. Okay, these are the simplifying rules. We also get to go back and forth between mixed numbers and fractions. Now you already kind of saw that a little bit with the earlier fraction example, but here we're going to look at the actual definitions. And from this point, we're going from a mixed number to a fraction notation. So what that means is we're going to the improper form. First thing you need to do is you have to do what's called multiply the denominator by the whole number, add it into the numerator, write it on top, and keep the denominator the same. Okay. So the way I like to remember it is I like to remember that we are going to do bottom times whole number. We also like to call that the big number, plus top goes to top. Bottom stays the same. So that's essentially what we are doing in a nutshell when we are going from one to the other. So let's take a look. I have 7 2/3. Okay. So I have 7 2/3, and I want to convert that over to a mixed number. Okay, so I want to know what that equals. So the way to find it is to follow your little saying. Bottom times the big number. So we've got 3 times 7 plus the top of 2 goes to the top, and then the bottom stays the same. So that is essentially over the top, bottom stays the same, which is 3. So all we have to do at this point is reduce the fraction. So here you can see that we're going to have 21 plus 2 over 3. So overall we're going to end with 23 over 3. Okay. And this would be the result that we were looking for. So let's look at it one more time. Again, we are going to do bottom times the big number, so 9 times 12, plus the top, which was 1, and then put it in the top, keep the bottom the same. So when we do that, we have 9 times 12, so this is going to be 108 plus 1 over 9. So when we reduce that all the way, we end up with 109 over 9. And this would be what we would have been looking for. Okay. So those are just two examples of converting from a mixed number over to its improper fraction. Once you go one direction, you get to go back again. So we can take that improper fraction and we can put it over into its mixed numbers. In order to do that, we are essentially doing old school long division. Okay? So what this is going to boil down is this is going to boil down to old school long division. Okay? In other words, what we mean is we are creating the big old division sign just like this, where we are going to put the top inside and the bottom number outside. And once we complete that long division, we are going to get a couple of new things. Okay, so one thing that we're going to notice is that my result on top, so this is going to give you your new top number, and then your remainder sorry, I did that backwards. This is going to give you your new whole number, and your remainder is going to give you your new top number. Okay. So, let's take a look at a couple of these examples so that you can kind of see how they work. So I have 76 over 5. So I'm going to set up to do my old school long division. So I'm going to put my division sign in, and then my top is 76, my bottom is 5, and so now I have to do my old school long division. So the first thing I do, if you remember, with division is we look at how many times does 5 go into your first digit. So we are looking at how many times does 5 go in to 7. Well, it only goes in once. I have to subtract the 5 away. 7 minus 5 gives me a 2. Then I carry down the term next to it, which makes this a 26. Now in this case, I have to look at how many times does 5 go in to 26. Well, 5 goes into 26 5 times, so this is a 5. 5 times 5 was 25, so I got to subtract that 25 away. Leaves me with one remainder. So again, we need to remember what all of our pieces are. So our bottom here is still the bottom. My result up here is going to now be the big number, or the whole number. And my remainder down here is going to be the new top number. So when we rewrite our fraction, we're going to write the big number first. So this is going to be 15. And then we're going to do our new top, so 1 over the original bottom, 5. And thus, 15 1/5 is what we were looking for. Let's do it one more time just so you can see it and really get an idea on how this works. So again, I'm going to set up my long division. The top number goes in it, so that is 325. The bottom number goes on the outside, so this is 8. So the first thing I need to look at is how many times does 8 go into 3? Well, it doesn't. So then how many times does 8 go into 32? Well, it goes into 32 4 times. 8 times 4 is 32. So when I subtract that, I get a 0. I still have to pull down my 5. So then, how many times does 8 go into 5? Well, it doesn't. So this becomes a 0. And lo and behold, that also now means that I have a remainder. So again, if I take a look at what I have, this number here is going to be your big number. This is still going to be the bottom. And this number is going to be your new top number. So if we write this fraction, we have 40, which is the big number, and 5 over 8. Okay? And so there you have it. Some more kind of information and examples on fractions and how we work with fractions. So if you have any questions, obviously, please let me know. Otherwise, remember, math really is bananas. So just keep smiling, ask tons of questions, have lots of fun with your math, and as always, I'll see you next time.